Hello, everyone. I'm Don Chu.
And I'm Brian Ray,
This is AI Podcasts in 26.1 minutes.
where you get
Latest info on AI,
meet the most interesting practitioners of AI,
people whom we like in AI,
people who'll answer our emails,
supplication of our future robot overlords.
why AI matters for everyone.
Learn all you need to know about AI today during your drive home.
We're here today with Avilay, a principal machine learning engineer at Unity, leading the development of cool new PaaS, platform as a service, to run Unity simulations at scale in the cloud. In the past, he's worked at Amazon, was part of the early team in Microsoft Azure, and has done his own startup in the field of machine learning now. Welcome, Avilay. I'm here with Don Chu. Yeah, Don, do you want to ask Avilay a couple questions about his past here?
Yeah, I know Avilay a little bit. As I shared with Brian, I shared with Brian that you're one of my favorite
One,
people.
I'm his favorite person,
And
but you're
uh,
two or three, right?
well, Brian's my best friend, but I you're my favorite person because you're more benign than Brian is, and I've always appreciated that about you.
You're off to a great start.
But to get the AI stuff started, Amelie, do you mind sharing with us what got you started with machine learning and then onto AI?
Yeah, absolutely. First off, I'd like to thank you guys for inviting me to this podcast. It's great being here. Um, and to answer a question, Don, on what got me started, I actually started on AI uh, pretty long time ago. I remember when I was a little boy in India, I was programming neural networks in C++ using perceptrons. We didn't have deep learning back then. Uh, I will not mention the year that was, but suffice it to say, it was pretty long time ago. I when I did my uh, grad school in CMU, I took a couple of machine learning courses. Back then, it was unfashionable to call it AI. My advisor said, "Don't use the term AI; it's a dirty word." Uh, and then I kind of got distracted by distributed computing, which was kind of up and happening. Got recruited by Amazon to work on the retail website, then joined Azure. Then got back into machine learning slash AI when I started doing my own startup, uh,
Right.
where we created a startup for mobile app owners for increasing user engagement. We worked with a company. One of our first customers was an app called The Hunt, which got acquired by Pinterest. We drove up their mobile user re-engagement by 4 times as compared to what they were doing by hand. And since then, I worked with a couple of other customers. One interesting one was a company that builds sensors for your socks. So these are fabric sensors that measure how you're running. And I did some work with them to create a recommendation system for buying shoes and to kind of recommend the best running periods and running times and whatnot.
So you're out of Seattle too. So both you and Don are uh, elbow to elbow there in the rainy city of Seattle. What is the tech scene like in Seattle for you? You've been over at Amazon, Azure, and now doing your own thing. What's it like to be in the heat of it in the rainy city?
Well, one thing I think I should highlight as well is Avilay was part of the team of 30 that launched Azure as we know it now. So he's being pretty modest about that.
Is that yeah? So how did that feel to launch Azure and be part of the early culture there?
It was good, and just a slight modification down there. It was a small team by Microsoft standards, so it was 60 people. Uh, but it was awesome. We did things that were pretty new at that time. Azure was actually the first to come out with a platform as a service concept before its time. AWS was mostly into infrastructure as a service or IaaS, and then of course Azure pivoted into the IaaS world, and right now it's doing really well. It's kind of the closest competitor to AWS, which is saying a lot. And it feels good. The tech scene out here is pretty cool. It's pretty varied. Um, and a little point of interest was that Don actually kind of pulled me into working on Python. I was mostly C++ and Ruby before that. Uh, and since then, we've had a pretty vibrant Python community here. C Sharp, obviously, because of the Microsoft interest. Um, but yeah, the tech scene is pretty happening. It's pretty vibrant. The startup scene not as vibrant as the Valley, I would say, especially for consumer startups. But the tech scene in general is pretty cool.
Well, your daughter is a Pythonista also. So,
Yes, she is 11 years old and she's already programming in
Fantastic.
Python. So I'm pretty proud of her.
but also going back to what you did as a startup founder for the Hunt, remind me how long it took you to build that first product that helped them get so much lift.
So there's an interesting story there. My co-founder and I, we kind of had talked to the Hunt's CEO, um, and he took a leap of faith on us and said, what, you guys, first time startup founders, but I like what you guys are doing. So the product that is described is very, very nice. This was on a Thursday. He's like, can I see a demo of it on Monday? We said, sure. The reality was we actually did not have a real product. This was more, we were doing more customer discovery. We did not expect somebody to say, sure, show me a demo. So this was in San Francisco. So we raced back home to Seattle, worked straight through day and night. And by Monday, we
How
had a
was it
prototype
was
to
it
show the
received?
CEO.
Was it perfect in every way?
Of course, no way. But he liked what he saw initially, right? And so then he had us kind of engage with his dev director. And from there, we kind of took it over and then kind of iterated a few times. And it took us, I think, a month or so to get it down to where it was working pretty good. And they were seeing good amount of lift. We introduced some more metrics into it, and they were able to actually measure the lift. And they actually gave us some good advice. Like we weren't mobile app developers, so we said, "Oh, lift means somebody clicks on the or taps on the message that we send them." And they were like, "No, no, that's a bad idea because people don't usually tap on a message that they see immediately. They just see it; it registers in their mind, and they might tap on it a week later. So even if the tap comes a week later, you still count it towards your metric, right?" And so they actually helped us along the way as well.
Well, in some sense, Tim Weingarten and their team at the Hunt became your startup's product managers, right?
Yeah, I mean, they really helped shape the product.
No, and it was a great result for them. From what I remember, you were addressing what, like 160,000 unique uh, users for them on a weekly basis
So,
with
so this is
the product.
basically a
Right.
product recommendation
Yep.
tool. It sounds like. Is that correct?
Um, yes, you could definitely view it as that. We wanted to make it a bit more than that. We wanted to have it as a conversational tool between the mobile app and the user. So, we would be like, hey, this is an item of your interest, or this thing is happening of your interest, or, a bunch of your friends are interested in this, so maybe you might be interested in this. So it went a bit beyond product recommendation, but at its core, we were using collaborative filtering based techniques, which, as it is kind of the go-to machine learning
And are you allowed to say,
algorithm for
or
product
can you say
recommendations.
what the underlying technology looked like in the Hunt?
In the Hunt, no, I don't think I'm allowed to say that. And I actually don't have much visibility into
Sure.
that. I can tell you about what we did for them. Uh, and that was, like I said, we started out building a very simple kind of naive based classifier. Um, then we started using Lucene and Stoller uh, for text based. So we would kind of mine the product description or the item description and the comments that users had made and kind of match those two, right? Using text based kind of TF-IDF based techniques, which Lucene and
Right.
Solar provided pretty nicely back then. And then we kind of moved into collaborative filtering. We started using a bunch of Python and scikit-learn. This is all pre-TensorFlow days, right? Uh, Kind of deep learning was kind of was versioning in the academia, and I had started hearing about it, but I hadn't actually gone
If
and
you were to go
figured out
back
what
and
it
do it
was.
again, would you do anything different
So,
given today's technology in space?
I mean, in terms of the technology space, it has matured so much, right? The machine learning world has matured so much. We're talking 2013, 2014, up, and now. Now we have TensorFlow, we have PyTorch, we have all these fantastic data munging tools, which we did not have back then. So yes, in terms of the actual technical implementation, it would look a lot different. And I suspect our kind of time to market would also be pretty fast.
Well, it was pretty fast back then, um, getting
Yeah.
something together for the hunt on such short notice. But I mean, even Spark was pretty new at that point, right?
Yeah, yeah. I mean, we were, I think, using Spark Beta.
Yeah, I remember the agony you had trying to get Spark to work on Azure.
Yeah, and this is again, this is pre-EMR supporting Spark, right? So EMR in AWS now supports Spark, which is kind of easy, makes it easy for people to use Spark. But this was pre that, and so we had to kind of set up our own Spark cluster. What helped was we were both from Azure, so we kind of knew a thing or two about distributed systems, so we were able to do that. But yeah, it was painful.
What can you tell us about some of the other startups, uh, Inrix, and Formian, and then your own Avilay Labs and things like that that you went through before Unity?
So Informian was the startup that we have been talking about so far, which was the mobile recommendation-based startup.
Mhm.
Um, Inrix is actually a company in Seattle, in Bellevue, actually, that does road traffic analytics. So what I did for them was they collect data of by GPS systems and other means from all over the world, and uh, they have a model to build traffic predictions or the speed at which traffic is going to flow on a given segment of road in the next minute. And so what I did for them was I built an analytics uh, website, an analytics offering. And so somebody could say, I want all of Washington State, and I want to know some traffic metrics in that, or I want to know what's happening on I-405.
So where would you get the data for that? I mean, where do you usually find data for all these projects, in fact, that have machine learning in it? Is that a challenge to find data, or is it just, provided pretty much by whoever you're working with?
The latter. In case of Inrix, right, they were already buying this data from a bunch of third-party providers, and they also had deals with uh, fleet companies where they would install their uh, uh, sensors in their trucks, and then they would send data to Inrix. Um, in case of Avilay Labs, which was my second startup after Informian, uh, which is where I was working with this fabric sensor company. It's called Sensoria. They're still around. Uh, Again, data was not a problem because they were collecting all this telemetry from their socks, right? From the socks that they were selling. They had all of this data, and they were like, "What do we do with it?" I was like, "Can you help us uh, monetize?" So for
So
real
you're
world problem,
gathering data from socks, is what you're telling me.
that's right.
That's fascinating.
Yeah. So what they had was they had socks, and they had a fabric circuit. Like you could see the circuit in the sock, right? And then they would have an anklet that you would snap onto the sock. And that anklet was an IoT device which had Bluetooth sensors in it. And that would talk over Bluetooth with your phone. So every so often, it would kind of sync with your phone, send all the telemetry data to the phone, and then the phone would upload it to the cloud.
And what information was gathered from these socks? Like the smell of Don's feet, or
My feet are embarrassingly smelly.
he also wears these compressors when he flies, which I hope work. What kind of data do you get out of socks there? Uh,
So things like the gait. I actually didn't even know some of the terms that they were using because I'm not an avid runner myself. But supination, pronation, that's the kind of position of your foot as
uh,
it's running and moving. Um, and that can be used to kind of compute the gait, uh, your stride length, your speed, um, and then a bunch of the stuff that the app gives out, right? So your location, so you might like running in a particular track. Uh, and we can suggest, hey, it's going to be sunny there tomorrow, so you might want to go and run there. You seem to be doing better there. And users would also submit what shoes they were wearing, because that's a big deal amongst runners. They need to get just the right kind of shoes. And so we would kind of correlate the shoe that you're wearing with your running performance, and then be able to predict that, hey, if you wear this other kind of shoe, you might run better.
Well, Brian's a champion distance runner. So this sounds like useful stuff for you. What's your mileage at now, Brian?
I run at least 15 to 10 feet a day to the bathroom and back.
Yeah.
But tell me more about this. What you have going on now in the last couple of years with the 3D simulations in the cloud. That sounds really fascinating. And then, what cloud would this be?
Oh yeah, this is extremely fascinating. I think it's one of the coolest things that I've done in the past, I don't know, 5, 6 years. Uh, so right now, we have our offering on Google Cloud Platform, but we are kind of thinking of providing this on all the major clouds, that is AWS and Azure. What this is doing is, say you have, so Unity is a game engine, right? It's used by game developers to build 3D games. For example, Pokemon Go was built on Unity. The first Assassin's Creed was built on Unity. Um, and so, it's like everybody thinks, yeah, sure, game engine for game developers. But what we found was a lot of other industries, like medical industries, robotics, autonomous vehicles, have also started using Unity because at its core, it's a 3D rendering engine, right? You can render a 3D
Hmm.
world. Um, and so they were like, okay, so we are rendering some realistic three-dimensional world, like an autonomous vehicle company might be rendering downtown San Francisco and driving through that to test out their AV software. And they're like, well, we need to do this at scale. We need to be able to run 1,000 instances of San Francisco with different road conditions and lighting and uh, and we want 500 of those instances to be in rural Montana where it's snowing hard. How do you do that? And so that is the service that we built. Right? That's what I've been working on for the past 6 to 10 months out here. Um, where we actually built the service where you can just submit any Unity build and declare what kind of instances you want, and we'll just scale it out for you.
And let me get this straight. So, if I want to create a simulation world
Hmm.
where I go to the grocery store, let's just say it's three-dimensional space and has a certain layout,
Hmm.
and every aisle is Don shoe. And usually, if I see Don at the grocery store, I turn the other way. But in
Hmm.
this case, I just sort of get stuck in the simulation world. Is that correct? And then would they build this themselves, or would this be something that you would build for an end client?
No, so this is something that the customers would build themselves. The good news here is Unity's user base is pretty big. Like in LinkedIn, if you look for uh, job titles along with software engineer and machine learning engineer, you have Unity engineer, right? So it's actually fairly straightforward to build a simulation in Unity. It's actually one of the easiest simulation builders that I've used. Um, and once you do that, like I can talk a bit more about the use cases, right? Because what you mentioned, Brian, about you walking down the grocery store. Um, think about Amazon Go, right? Where uh, you literally walk down the grocery store, pick items, and walk out, right? How did they train their models for that? I mean, I don't know how they did that, but if I were them, I would need a huge data set of grocery store items, right, to train my models on. Um, and For machine learning, computer vision purposes, kind of the go-to data set for vision is ImageNet, which has around 14 million images, 20,000 different categories. And it took them 2.5 years to build this data set. With using something like simulations in the cloud, we call it elastic simulations, you can do something like that just for grocery store items in 2 days. Right? Um,
Okay.
does that kind of clarify the use case?
So also, sounds like the people using your product are training their models using these simulated
Yeah.
environments. Okay.
So
Yeah,
they can.
it sounds
So
great. I mean, so it sounds like if you, but usually when I think of a model training data, like a ground truth training data, would there be labels associated with this? So would they create a simulation that you already know it's Don that's standing
Mhm,
there in the aisle, and that they
mhm,
provide that information as input to be simulated. Then everything else is simulated around the known Dons in the world, and you add
exactly.
noise and you add different layers to that. Is that how it works?
Exactly how it works. So, in think of a real, well, a natural photograph, right? Like the ones that ImageNet has. Some human being had to painstakingly go and label all the things they could see in that photograph. Right? They could
mhm,
see a dining table, a few chairs, maybe a drink, some table mats, whatnot. Right? Here, because all the content is being rendered programmatically, the program knows it's rendered a dining table. Right? It knows it's rendered Don there. So it can just label Don. It said this photo has a Don, and here's the bounding box around. Right. So that's the power of this. You can actually create label data sets very fast.
That is extremely fascinating, and it sounds like from socks, to simulations, you've really to Azure, you've really touched on the gamut of machine learning, probably even early dating from CMU to now. So
Mm-hmm.
what's next? And we've got about 3 minutes left or 2 minutes left. You sound like you would know the future. If anybody knows the future, it would be you. What's next?
Yeah, I wish I knew that, but I can tell you what next is exciting to me. And to me, I think quantum machine learning is something that is very interesting to me. Uh, at its worst, it'll probably be have the same kind of impact that GPUs and TPUs have had, where it's a very powerful new compute resource. And if we actually achieve what is called quote unquote the quantum supremacy, uh,
Quantum
sky's the limit.
supremacy. So quantum machine learning. So does that mean that it's machine learning on quantum computing? Is that even invented yet? Does that exist
Uh-huh.
yet?
Yeah, it does. It does. There are certain models that you can actually run on quantum computers. There's, in fact, a really cool course on edX called Quantum Machine Learning. If you're interested, you should check it out. Uh, I have a couple of blogs on that as well. It's a very active field of research, but you're right. It's doing machine learning on quantum computers because you can do optimization really well on quantum computers.
Fascinating.
Brian, I thought you had an interest in quantum computing. You've been tracking it.
I cannot keep up hardly with TPUs and GPUs, not to mention quantum computing. Now, what quantum computing could mean is if I was doing a deep neural network,
Hmm.
I could somehow do the back propagation faster, or I could have more registers to compute on, or fill in the blanks for me here. What does it really give me on a technical level?
At a technical level, you probably might not even need backpropagation at that point, right? Because you can solve your cost function optimization problem in a different way. Uh, Maybe using differential equations, in which case you would need backpropagation to calculate the differential equations. Maybe not. And that again is a pretty kind of active area of research, how to solve quantum optimization problems. But essentially, everything else remains the same. Your cost function optimization, you offload to a quantum computer, which processes it far more efficiently than classical computers do.
Now, this is fascinating. And I thank you very much, Avilay, for the time today. Any last kind of we're about a commute level deep into this, and that's what we try to keep this to. That's why it's 26.1 minutes. But
Mhm.
any closing thoughts or something you want to tell our 300,000 listeners?
Closing thoughts, check out Unity's cloud computing, cloud simulations. We hope to make an announcement in Unite Copenhagen sometime later next month.
Ooh, can I
And
come?
was that?
Can I come? Can Don and I come? Can we visit you in Copenhagen?
Absolutely. I'll send you the contact.
What
Uh,
do you say, Don? Are we going to go to Copenhagen?
Do we have a budget?
Just like the last time we went to San Francisco, Don. Same budget.
Yeah, same budget. So you're going to leave me at a hostel?
Yeah. Yes. Basically.
Yeah, yeah. But also a little shtick I'm trying out is, what's your attitude about AI, Avilay? Are you optimistic? Is it going to free us from drudgery and liberate human creativity, or are we preparing for the coming tyranny of robot
no, no,
overlords?
I'm super optimistic, right? Otherwise, I wouldn't be in this field. Tyranny of robot overlords, man. That's like, yeah, sure, singularity can happen one day, and we can have evil robots. We cannot live in fear, right? It's like how Steve Jobs compared computers to the bicycle of the mind. I think that comparison is kind of apt for AI as well. It's kind of taking our civilization to the next step, right? Just like agriculture took it forward, then wheel took it forward, then industrial revolution took it forward, internet, computers, and AI. Right?
Well, that was a great episode, and Avilay, we thank you very, very much for joining us today. Obviously, one of the leading machine learning experts in the world right now, working on fascinating stuff.
Thank you.
Thanks for stopping by, and we really appreciate it. That's a wrap. Thank you for joining us on AI Podcast. You can reach us at ai-podcast.com or find us on Spotify or iTunes. Thank you again, and we'll see you soon.